In this video, we will talk about MongoDB, a NoSQL database. You might have a background about what a database is in your CMSC 127, but if not, database is an organized collection of data. Our applications generates and use a lot of data, and we wanted to efficiently store this data. Hence, we use a database. In CMSC 127, you tackle both SQL databases or relational databases where you have a structured schema and you use foreign keys to show relationship between tables. You also tackled about NoSQL, which are non-relational databases. NoSQL or not only SQL databases. These are the type of databases that are a lot flexible than SQL database. It accommodates rapid changes and it provides flexibility in modeling unstructured data. In this video, we will talk about MongoDB. MongoDB is a NoSQL document database. In MongoDB, we store data in a JSON-like format called a document or sometimes called a record. If you're not familiar with JSON, JSON is JavaScript object notation, basically uses a key value pair to represent data. So to learn more, let's visit the official site. Open your browser and go to mongodb.com. To set up MongoDB in our devices, click Try Free. And as you may see, MongoDB offers a lot of services, but we wanted to install MongoDB in our devices, so click On-Premise. MongoDB offers both community version and enterprise version. Community version is the free and open document version, while the enterprise version is a lot powerful but comes with a price, so let's just stick with the community version. On the right panel, make sure to choose the current version and your platform. I am using Windows, and for the package, let's just have the MSI or the Windows installer. Once the download is done, open the file and proceed with the installation. In this version of MongoDB, we can configure it as a Windows service. That means that it will automatically run in the background without explicitly running the Mongo daemon to run the server. If we install MongoDB as a service, we just go ahead and open a command line to interact with the Mongo shell. Open the command prompt and make sure to run it as administrator. Navigate to the bin folder of our installation directory and run mongo.exe. This will open the Mongo shell. Here, we can type our commands. To validate that we are indeed connected to our database server, let's try to print the database that comes pre-installed with Mongo. Let's type show dbs. We can see here 3 default databases. Now, this Mongo command will only be recognized inside of this folder. To save time from the hassle of navigating back to this bin folder every time, let's just add this bin directory to our environment variables. To do that, just copy the directory, search environment variable. We have here the system properties. Open environment variables, and on the system variables, look for the path. Let's add our MongoDB bin directory. Click OK and close. Now let's restart our command prompt. To show our databases, we use the command show dbs. So right now we have here 3 databases that comes pre-installed with MongoDB. Let's try to create our own database. To select or use a database, we use the command use, followed by the name of the database. If the database is not yet existing, Mongo will create the database for us. So I will do use uplb. When we use a database, all of the commands we do will affect this database. If we insert, update, or delete any data, it will be referring to this database. Let's print again our databases. As you may see, database uplb is not yet listed here because it has no data yet. To confirm, we can do show collections. This is somehow similar to printing all the tables in SQL databases. So since we have no collections yet, nothing printed. Let's try to add a data. In NoSQL, our unit of data is called a document. If SQL databases have tables that are composed of rows or tuples, in NoSQL we have collections that contains document or sometimes called records. A document in NoSQL is written like a JSON or a JavaScript object. We declare contents of our data in key value pairs. We can also have arrays of values, and we can also nest our data. To insert the data in MongoDB, we use the command db dot the name of the collection dot and then the function insert. In the insert function, we use our data as parameter. If the collection name has a dash on its name, we have to enclose it in a single quote. As of now, we have no collection in our UPLB database. And if we try to insert a data to a non-existing collection, Mongo will automatically create the collection for us. So I already typed my sample data, medyo mahaba kasi siya, and formatting isn't really that good in the command line. I will first try to insert a single data. Let's say db.subjects. Subjects is the name of our collection. .insert. And inside the parentheses, I will place our data. So we don't have any error, and we have here a note that we have inserted one record. So if we print out our collections, we now have the collection subjects since it already has a data. We can also insert multiple data at once. We use the command db dot name of the collection, in this case subjects, dot insert many. And then inside, we put our data. Since this is a multiple data, as you may notice, I insert an array of data because I wanted this to be inserted as individual documents. Now that we have documents in our collection, let's try to query some data. Querying data in MongoDB is somehow different. To print all the data or similar to a select all statement, we use the function db.name of the collection.find. As you may notice, yung ating pattern, we always start with db, which references our current database, followed by a dot, and then the name of the collection, and then we have a function call. So we can think of it like we are triggering this function, find, of the collection subject inside of the database UPLB. If you wanted to select a specific value, let's say db.subjects.find, and inside of the parentheses, we enclose here a key value pair. We have code and then the value of the code that you wanted to search. You can also add more key value pair in this query if you wanted to be more specific in your search. Just separate them by a comma. MongoDB also provides flexibility in searching in terms of regular expressions or regex. For example, db.subjects.find, and instead of putting a specific value, we can use a regex. So if you're not familiar with regex, we use them in pattern matching for searching. If it's a regex value, we enclose it with a slash, no quotation mark. Let's try to query subjects with code ending in 100. So we can do db.subjects.find, and then again we have the field code, and our regular expression we have .*100. So this will query all the subjects with code ending in 100. To review the patterns for regular expression, I will just leave a link in the video description of regular expression cheat sheet, or you can just read more about regular expressions as a reference for better querying experience. In MongoDB, we also have comparison operators. For example, if you wanted to query a subject with more than 40 students, ang syntax natin is db.name of our collection, subjects.find. And then inside of the parentheses, we have here a key value pair. Ang field natin is students because that is the field that we wanted to search. And then for the value, we have here another key value pair, which is this key, $GT, and then for the value, we have 40. So this translates to, let's query subjects with students greater than 40. So for each comparison operators, they have their own equivalent syntax. For example, for equality, we have EQ, and then GT greater than, GTE for greater than or equal, LT for less than, LTE for less than or equal, and then NE for not equal. Or we can also specify an array of values. For example, db.subjects.find, and then we have again the field code, and then we use the syntax in, specifying that we wanted to search all of the matching code in this array. So let's have CMSC100 and CMSC2 for example. So we will get the documents with subject code CMSC100 or CMSC2. If you wanted the other side, let's just specify not in. Now this will return all the subjects that are not equal with CMSC100 or CMSC2 as their code. Now that we know how to query our data, let's try updating or modifying our data. This is the syntax. Same pattern to start, we specify db dot the name of the collection dot, and then we have here the update function. Inside the update function, we have three parameters. First parameter is the search query. We will specify in this part our selection criteria, similar to what we do in our find function earlier. The second function is the update part. Here we will write the update that we wanted to apply, similar to what we do in the insert. And lastly, we have here a set of optional flags. The update function will still work even if you do not include this last part. First is the upsert. Do we want to create a new document if no document matches the query? If yes, it will create a document containing the data from the update part we specified if there are no matches. By default, this is false, so it will not create a new document. The second one is the multi flag. If there are multiple documents that match the query, do we want to apply the changes to all matches or only on the first match? By default, again, this is false, but if you wanted to apply the changes to all matches, just set it to true. So let's try a simple update. First, let's print all our data. So db.subjects.find. I want to change the description of CMSC100, so I'll try db.subjects.update, and then on the query part, I will write here code CMSC100. And then I will update the description, web app development. As you may see, if we print again the data, we destroyed the document, or at least this is not the change that I want. This is because the update replaced all the data to just the data we specified. Also, if you may notice, NoSQL is very accommodating of how unstructured our data is. On our first document, it completely does not have the code field anymore, but it's just okay. So let's try to correct that. First, let's undo our changes. So there's no shortcut to undo, so what we can do is we just update that particular document with its original content earlier. Or alternatively, we can just delete this whole entry and just insert a new one. Now let's print the data again. If I wanted to correctly change the description, I need to use the set keyword. This tells Mongo that I wanted to retain all the information, but just set this particular field to this value. So here's how it looks. Notice that the field set has a value in it, which specifies the field to be modified and the new value. Now let's try to update multiple values. Similarly, we use the update function, but first let's search all the subjects with code CMSC using regular expression. And then let's set the description to this is a CMSC subject. And for the flag parameters, we used the multi and set it to true because we wanted all the matches to reflect this change. So it seems like our edit successfully reflected. Now, all our CMSC subjects has the same description as we specified. On the other hand, we can also remove a field in our document, just like what we accidentally did in our first attempt to update. To do that, we can use unset instead of set keyword. Let's try to completely remove the description field of all the documents. So we will leave the search query blank to match with all of our documents. And then on the modification part, we use the unset keyword. Let's unset the description. Despite that we are unsetting, we still need to comply to the format. So since this is a key value pair, let's just put a blank text. And then we wanted to apply this to all matches, so we set multi to true. Here we have 4 documents modified. And if we print again, we now completely remove the description field. This isn't just setting the field to null, it completely removed it from the document. Okay, so now we know how to query and update our data. Let's try to delete some data. Intuitively, we will use the remove function. To remove a document, we use db.name of the collection, which is subjects. In this case, we use the remove function. Inside the remove function, we put our query, similar to what we do in find and the query parameter in update. So let's try to delete CMSC subjects. By default, this will delete all matches. But if you want to specify that we just wanted to delete the first match, we just have to put 1 as second parameter. Let's try to delete the first match of chem subject. If we wanted to delete all the contents of a collection, we can also empty our collection using the command dp.collectionname.remove, and then we will just put blank curly braces inside of our parameter. This will wipe out all the documents inside this collection, but it will not delete the collection itself. If we want to completely remove a collection, we have to use the drop function. So db.collectionname.drop, this will entirely delete the whole collection. So if we show all the collections, our collection is completely deleted. In database, we can also dump our data. When we dump our data, we export or create a backup with our frozen data. So even if we delete or drop our database, we still have a backup we can use as a restore point. The current version of MongoDB that we are using in this video is version 4.4. Starting version 4.4, MongoDump and MongoRestore, the tools used to backup and restore data in MongoDB, no longer comes pre-installed. Instead, they are now separately released with other MongoDB tools with their own versioning. So to use them, we have to download them. To do that, open again your browser on the same page where we downloaded our database server, mongodb.com/try/download. Here, let's select Tools, and then select MongoDB Database Tools. On the right side, select the current version, which is 100.3.0, and I'm using Windows. I'm going to download the window installer. Once the download is complete, open the installer and proceed with installation. Unfortunately, it will not install on the same bin directory as our server, so we have to locate it in our program files and set up our environment variables to include the bin folder of MongoDB tools. After setting up our environment variables, let's restart our command prompt. Now let's try to dump our data. When we use MongoDump, it will dump the data on the current directory, so I want to export it on my desktop. Now that we have exported our data, let's drop the database. To drop a database, we need to use the database and type the command db.dropDatabase. This will delete the whole database with its content. Let's check all the databases, and now we have deleted UPLB database. Now let's try to restore it from the files we exported. So that is mongo restore space name of the folder where we dumped our files. Let's check if we have our data back. Now, we have successfully restored our data.